Welcome back. Let us look at this IC, which is CD4017, which is decade counter IC. Here we have the output pins. We have the VCC, which is power supply, and the VCC, which is negative power supply. So output 5, output 4, output 0, output 2, output 6, output 7, and output 3, then GND, negative power supply. We have VCC, we have reset pin. This is set pin 15 is to reset the clock, of the IC. This CLK, this is clock input. This CLK inhabit. This is the line that inhabits or disable the clock input. Carry out. This is for cascading, or used if you want to connect two or more ICs. And then you have output 9, output 7, output 8. So we'll use this outputs as we can use Q to represent the output. This is our 16 pins deep socket IC. So I'll use pin 3, pin 2, and pin 4 for the outputs here. So which is Q0, Q1, and Q2, total 3 pins. I'll connect them to leads to see its function. And I'll use a 104, this is code, which is 100 picofarads, 103 is 10 picofarads capacitance. So here guys, here it is a circuit diagram for the IC Q5. So I'll start with Q5 is open, Q1, then Q1 which is pin 2, Q0 which is pin 3, and Q2 which is pin 4. We'll connect them to the lead as shown in the diagram. DSS connected to ground pin 8, VCC to pin 16, reset pin to pin 15, pin 14 is the clock input pin, which is provided with pin 3 of the 55 timer. Then CO, it is carry out pin 12. The other pin 11, 10, and 9 are open. Then we have active reset pin will be active high, and it is being supplied with the pin 7, which is Q3. So when the clock counts, when the timer counts 1, 0, 1, 2, when it's come to 3, the clock will reset back to 0, and then 1, 2, 3. So this is the schematic diagram showing all the pin configuration or pin arrangement. So this CD4017, it is being fed with a clock from 55 timer. IC 55 timer, this is 555 timer. So 55 timer IC pin 3. And then this IC 55 timer pin 1 is ground, pin 2 is trigger, which is connected to capacitor of 10 microfarad between pin 2 and pin 1. Pin 3 is the data output. Pin 4 is the reset pin, reset of the clock, and is connected to VCC. Pin 5 is connected to 100 picofarad capacitance. So this pin 5, capacitance of pin 5 and capacitance of pin 2 is used for timing for timing of the clock. Then pin 8 is VCC, which is power supply positive, and it is 5 volts. And then between pin 8 and 7 I have a 20 kilo ohms resistor, and then between pin 7 and pin 6 I have a 50 kilo ohms resistor. These two resistors, it divides the voltages. It divides the voltage according to the resistance value of these two pins to provide pin 7 with the voltage. This voltage will determine the output clock. So let's see the true function of the decade counter with 5/5 timer. So I have them here full connected. Then I have the power supply, which I supply from my charger, which is 5.2 volts. I supply them, so I feed them to the VCC line, or power supply positive and power supply negative. Power supply positive and power supply negative. So let us look at the output, how it is going. You'll see that this Q1, it received the signal from 5/5 East, it received the signal, and then after that Q1 and then Q2. So it is Q0, Q1, Q2, Q0, Q1, Q2. So that is how this 5/5 timer and CD4017 works in together. So this timer and this and this clock are being connected to do a certain function. Let's say application like binary counters, you can use them for that. Frequency division, because there is a frequency division of 4 or 5. There is counter controls, you can use in counter controls, because the data, it goes in serial data and parallel data output, but this data output is shift from one pin to another, from Q0, Q1, Q2, Q3, Q4, Q5 up to Q9, which is 10 pins, which is 10 outputs, and then return to 0. But here I have connected that Q3. When the clock reaches Q3, it returns to Q1. Thank you.